Hello and welcome to Saurav's classes. Today we are discussing the CAT 2021 Slot 3 QA questions. We come to question number 13. This one says a 4-digit number is found by using the digits 1, 2 and 3 where 2 and 3 appear at least once. So what would be the number of such 4-digit numbers? So let's see. According to the conditions, 2 and 3 has to appear at least once. So let's put 2 and 3 as two of my numbers. Now the other two numbers can be 1, 1. So with this combination I can have, this can be permuted in factorial 4 by factorial 2, which is 12 ways. Then I can have 2, 3 and 1, 2, and this can be done in factorial 4 by factorial 2 ways, which is once again 12. Then I can have 2, 3 and 2, 2. This can be done in factorial 4 by factorial 3, that's 24 by 6, which is 4 ways. Then I can have 2, 3 and 1, 3, and this can be done in factorial 4 by factorial 2, which is 12 ways. Then I can have 2, 3 and the other two can be 2, 3, and this can be done in factorial 4 by factorial 2 into factorial 2, that's 24 by 4, which is 6 ways. And then I can have 2, 3 and 3, 3, and this can be done in factorial 4 by factorial 3, which is 24 by 6, that's 4 ways. So the number of all numbers that can be formed will be the sum of all these numbers, 12, 12, 4, 12, 6, 4, which would be 12 times 3 plus 14, that is 50 ways. So there can be 50 such numbers that can be formed. We move to question number 14. This one says that in a triangle ABC, angle BCA is 50 degrees. So let's draw the triangle first. So we have a triangle ABC where angle BCA is 50, so this angle becomes 50. D and E are points on AB and AC respectively, such that AD equal to DE. So let's say this is my point D and this is my point E. So AD becomes equal to DE, and F is a point on BC such that BD equal to DF. So BD should be equal to DF. Then angle FDE in degrees, so we need to find this angle. So it's very simple. So we see an isosceles triangle ADE. So if this is X, then this will be X. So that means in the big triangle ABC, we have 50 degrees, we have X. So angle B will be 180 minus 50 plus X. That's 130 minus X. So this is 130 minus X. Now triangle BDF is also isosceles, so this angle will be also 130 minus X. So this angle becomes 180 minus 130 minus X, that is 180 minus 130 minus X, which is 50 plus X. So this angle becomes 50 plus X. Now this angle would be 180 minus X. So now we look at the quadrilateral DFC DFCE. So in quadrilateral DFCE, we know three of the angles in terms of x: 180 minus x, 50 plus x, and 50. So if we add these three up, that gives us 180 minus x plus 50 plus x plus 50, which is 180 plus 100, that's 280. So the remaining angle will be 360 minus 280, that's 80 degrees. We come to question number 15. This one says that we have a sequence of real numbers x1, x2, x3 such that xn plus 1 equals xn plus n minus 1, and x1 is minus 1. We are asked to find x100. Now this is a very common problem that comes very often. So whenever we are given a relationship of the form x plus 1 equals xn plus some function of n, then we write this as xn plus 1 minus xn equals that function of n, and then we put values of n starting from 1 up to whatever value is given. So we'll follow the same logic here. So here we have xn plus 1 minus xn equals n minus 1. So you start putting values of n starting from 1. So if I put n equal to 1, then I get x2 minus x1 equals 1 minus 1. x3 minus x2, when I put n equal to 2, x3 minus x2 would be 2 minus 1. x4 minus x3 will be 3 minus 1, and this will continue up to x100. That means I am putting n equal to 99, so that n plus 1 becomes 100, minus x99 equals 99 minus 1. So now if I add up all these numbers, then on my right hand side, on my left hand side, these all will get cancelled. So all these numbers will get cancelled, and what will remain is x100 minus x1, and on my right hand side I have the sum of numbers 1 to 99, which will be of the formula of the sum of the first 99 natural numbers. Now we know sum of first n natural numbers is n into n plus 1 by 2. So this would be 99 into 100 by 2 minus, we have 1 to 99, so there are 99 ones, so minus 99 will be x100 minus x1, which is minus 1. So from here x100 will be equal to, you take 99 common, so 99 into 100 by 2, that's 50 minus 1 into 49, and then you have plus 1 which goes to the other side, minus 1. So this becomes 99 times 49 is 4851 minus 1 is 4850. We move to the next question, number 16. This one says, this one is a theta question again, no negative marking. So this one says a tea shop offers tea in cups of 3 different sizes. The product of the prices in INR of the 3 different sizes is equal to 800. So let the size be large, regular, and small. So the prices of the smallest size and the medium size are in the ratio of 2:5. So let's take this as medium. So the prices of smallest and medium are in the ratio of 2:5. So let this be 2x, then this is 5x. If the shop owner decides to increase the price of the smallest and the medium ones by ₹6, keeping the price of the largest size unchanged, the product then changes to 3,200. Then find the sum of the original prices of the 3 different sizes. So now we are not given the price of the largest one, let this be y. So the product is 10x square y, and this is given as 800. And if the price of the medium and small are increased by 6 rupees, then this becomes 5x plus 6, and this becomes 2x plus 6. This remains as y. So that means we get 5x plus 6 times 2x plus 6 into y is equal to 3200. Now this is a very simple one. So we can see that if I take the quotient of the second and the first, then I divide the second equation by the first equation, I get 5x plus 6 times 2x plus 6, that's 10x square, and then 30 plus 12 plus 42x plus 36 upon 10x square is 3200 by 800, that's 4. So 10x square plus 42x plus 36 equals 40x square. So transposing everything to one side, we get 30x square plus minus 42x minus 36 is 0. Divide by 6, we get 5x square minus 7x minus 6 equals 0. Now this is a very simple one. 5 into minus 6 is minus 30. We have a minus 7, so it should be 10 and minus 3, minus 10 plus 3. So 5x square minus 10x plus 3x minus 6 equals 0. So 5x into x minus 2 plus 3 times x minus 2 is 0. So x minus 2 times 5x plus 3 equal to 0. Obviously x is a price, so it can't be negative, so x has to be equal to 2. So which means that the prices of the small and the medium are, small will be equal to 2x, that's 4, medium will be 5x, that's 10, and the large one will be 800 by 10 into x square, 10 into 4, that's 20. So the sum of the original prices of the cups will be 20 plus 10 plus 4, that's 34. We come to question number 17, which is a very simple question on log, and we'll use the basic property of log. So if I simplify this, this becomes log a to the base 15 divided by log a base to the base 15 times log a to the base 32. So this becomes 1 by log a to the base 32 plus 1 by log a to the base 15 equals 4. So log a to the base b is log a by log b. So this becomes log 32 by log a plus log 15 by log a equals 4. That means log of 32 times 15, log a plus log b, is log of a into b. So 32 into 15 is 4 log a. That means 32 into 15, which is 480, equals a to the power 4. 4 log a will be log of a to the power 4. So 480 is a to the power 4. That means a square will be square root of 480. So that means 480 is definitely less than the next square is 484, which is 22 square. This is 22 square, and this is greater than 441, which is 21 square. So a square lies between 22 and 21. So which means that it is definitely greater than 16 and less than 25. That means A has to be greater than 4 and less than 5. We come to question number 18. This one says a park is shaped like a rhombus and has an area of 96 square meter. Area of 96 square meter. If 40 meter of fencing is needed to enclose the park, then the cost in INR of laying electric wires along its two diagonals at the rate of 125 per meter is what? Now let's draw the diagram. So we have a rhombus like this, and it is said that 40 meter of fencing is needed to enclose the park. That means each side is 10 meters. So each side is 10 meters, and we have to find the diagonal, the length of the diagonals. So we know that in a rhombus the diagonals intersect at 90 degrees. So if the length is x and y, then this is x by 2, this is x by 2, this is y by 2, and this is y by 2. So from simple Pythagoras we can see x square by 4 plus y square by 4 is 100, and it is given that the area is 96. Now we know that the area of a rhombus is half into product of the diagonals. So half into xy is 96. That means xy is 192 and x square plus y square is 400. So x plus y whole square will be x square plus y square plus 2xy. That would be 400 plus 384, which is 784. So x plus y is 28, and x minus y whole square will be x square plus y square minus 2xy. That would be 400 minus 384, that's 16. So x minus y will be 4. So which means we solve for x plus y 28, x minus y is 4, that means 2x is 32, x is 16, and y would be 28 minus 16, which is 12. So the diagonals are of length 16 and 12. So that means the total length of the diagonals would be x plus y, which is 28, and the cost of laying cable is 125 per meter. So the total cost would be 28 into 125, which would be equal to 3,500. So the cost of laying the cable would be 3,500 rupees. We move to question number 19, which says one part of hostel's monthly expenses is fixed and the other part is proportional to the number of its boarders. So that means the cost will be fixed plus number of boarders into variable cost per boarder. So this would be the total cost. The hostel collects 1600 per month from each of the boarder. That means the revenue per boarder is 1600. When the number of boarders is 50, the profit is 200 per boarder. So the profit per boarder will be the revenue minus the cost per boarder, which will be 1600 minus the cost divided by n. So this would be C by n. That will be F by n plus V. So this will be the profit per boarder. So it is given that when the number of boarders is 50, profit is 200. That means when n is 50, the profit is 200. So that means 1600 minus f by 50 plus v is 200, and when the number of borders is 75, profit is 250. So when n is 75, profit is 250. So 1600 minus f by 75 plus v will be 250. Now these are two very simple equations. You just subtract the first one from the second one, and you will get f by 50 minus f by 75 will be equal to 50. So that means f will be equal to 1 by 50 minus 1 by 75. So 50 into 75 by 25. So that gives 3. So 2500 into 3, that's 7500. So the fixed price or the fixed cost is 7500, and put this value in any one of the two equations. So if I put it in the first equation, I get 1600 minus f by 50. So 1600 minus 7500 by 50 would be 150, minus v is 200. So v would be 1600 minus 350, that is 1600 minus 350 will be 1250. So the variable cost per border will be 1250. So the profit when the number of borders is 80, the total profit, okay, here they are asking for the total profit. So total profit will be total revenue, that means revenue into n minus total cost, which is f plus nv. So total revenue will be 1600 into 80 minus f is 7500 plus 80 into v, that's 1250. So simplifying this, I get 80 into 1600 minus 1250, that's 350 minus 7500, which is 44, 83, 24 and 4, 28 minus 7500, which is 20500. Next one is a problem on parallelogram. ABCD is a parallelogram. Length of AD and diagonal AC are given as 10 and 20. Angle ADC is given as 30. Then they are asking for the area of the parallelogram. So let's draw the parallelogram first. So ABCD is my parallelogram. So ABCD is the parallelogram, and it is given side AD is 10 and the diagonal AC is 20 and angle ADC is 30 degrees. So the height we need, so the area of the parallelogram will be base into height. So we know the base, we have to find the base and the height. So the height will be AD sine 30, which is 10 into half, which is 5. So the height is 5, and the base will be calculated in two parts. So DE will be AD cos 30, which is 10 into root 3 by 2, and this would be equal to 5 root 3, and we know AC is 20 and AE is 5, so CE would be 20 square minus 5 square, square root of that, which is square root of 375. That's 25 into 15, so which is 5 root 15. So that means the total length of CD would be 5 root 3 plus 5 root 15, which is 5 into root 3 plus root 15, and the height is 5, so the area will be 25 into root 3 plus root 15. We come to question number 21. This one says that the total of male and female populations in a city increased by 25% from 70 to 80. During the same period, the male population increased by 40, female population increased by 20. So let's draw a table, make a table. So male, female, and 1970, 1980. Now let's say the male population was X, so that increased by 40%, so this became 1.4x, and the female population was Y, this increased by 20%, so this will become 1.2y. So the total population in 70 was X plus Y, and in 80 it becomes 1.4x plus 1.2y. Now this is 25% more than the population at in 1970. So this is 1.25 times x plus y. So from here we can find a relationship between x and y. So 1.4x minus 1.25x, 1.4x minus 1.25x, that's 0.15x, equals 1.25y minus 1.2y, that's 0.05y. So that means 3x equals y. So this is the relationship between x and y. Now in the second part it said from 1980 to 1990 the female population increased by 25%. So that means in 1990 the female population will be 25% more than 1.2. So 1.25 into 1.2y, that would be 5 by 4 into 6 by 5 y, which is equal to 1.5y. So the population of female population in 1990 would be 1.5y. If the female population is twice the male population, then the percentage increase in the total of male and female population from 70 to 90. Female population is twice the male population in 1990. That means the male population will be half of this. That means this should be 0.75y. So the male population in 1990 will be 0.75y. So the total population in 1990 will be 0.75y plus 1.5y, that's 2.25y. This is the total population in 1990. And the total population in 1970 was x plus y, where x is y by 3. So this was y plus y by 3, which is 4 by 3 y, and this would be 225 by 100, that's 9 by 4 y. So the percentage increase in the total population from 70 to 90 would be 9 by 4 minus 4 by 3 by 4 by 3 into 100, which is 27 minus 16, that's 11 by 12 by 4 by 3. So this goes 4 into 100, so that's 11 by 16 into 100, so which goes 25 4, so that's 25 times 11 by 4, so which is 275 by 4, which is 6 35, that's 8.75, 68.75%. We come to the last question of this section, which says the arithmetic mean of the scores of 25 students in an exam is 50. So the total score will be 25 into 50, that's 1250. This is the total score. 5 of these students top the exam with the same score. So let the same score be x. So this is the maximum score, 5x is the total score of 5 students. If the scores of the other students are distinct integers with the lowest being 30, then the maximum possible score of the toppers is what? So 5x plus the sum of 19 students, and we don't know what this is, plus 30, which is the lowest score, is 1250. So that means 5x is 1250 minus 30, that's 1220 minus 19, score of 19 students. Now we have to maximize this, and to maximize this we have to minimize this. Now if I have to minimize this, then the logic is that the scores of these 19 students being distinct integers have to be in an arithmetic progression starting from 31 to 49. So the scores of these 19 students will be 31 to 49, and this is the minimum possible scores that they can have based on the given condition that the lowest score is 30 and the scores are distinct integers. So the sum of this would be 19 by 2 into 31 plus 49, which is 19 into 80 by 2, that's 40, which is 760. So 5x is 1220 minus 760, which is 460. So x is 460 by 5, that's 92. So the maximum possible score of the toppers is 92 each.